Problem 2.43. In this problem, we have an inclined tube manometer shown in the figure below. In this one, we have pressure in pipe A to be 0.6 psi. The fluid in both pipe A and B is water, and the gauge fluid in the manometer has a specific gravity of 2.6. We need to determine the pressure in point B, or in pipe B, corresponding to the differential reading shown. Okay, so we're going to label the points that we're going to use in our analysis. We have A. We're going to use this as point 1, this as point 2, and we're going to label the heights. I'm going to use this to be H1, and the elevation that we will have in the vertical component over here, I'm going to be H2, and this is going to be H3. Okay, we're looking for pressure at point B, and we start at point A. So we do PA, and then we go from point A to point 1, we go down, therefore it's positive. So we go gamma of water, which is the fluid, times the elevation between the 2 points. Then we go from point 1 to point 2. It's going up, therefore it's negative. And we go gamma of the fluid times H2. And then we go from point 2 to point B. Once again, that is negative because we're going upwards. And that is gamma of water times H3. Okay, so we're going to substitute in the values that we have. We have PB, once again PA, the gamma of water we have, and H1 we have. However, we don't have the gamma of the fluid. We do, however, have the specific gravity of the fluid. That is going to be Sg of the fluid times gamma of water. Then we stop over here because we don't have the elevation H2. However, we have this triangle. We have this is elevation H2. This is the L, the length that we have, and this is the angle theta. In this case, it's 30. We know that sine of this angle theta is going to be H2 divided by L2. Therefore, H2 is simply L2 times sine of the angle theta. So we substitute it back here. Then we have L2 times sine of the angle. And then once again, we have gamma of water times H3. So I suggest you to write the equation first, then we substitute. Now that we have all the components, then we substitute. The value of PB is equal to 0.6 psi. That's what we have for point A. Gamma of water is going to be 62.4 pounds per feet cubed. This elevation is given in inches, so we're going to do 3 inches. And we're going to convert it to feet, so we're going to just do 12 inches. And this becomes 1 foot. And then we do the same process for all of the remaining. So this one is negative 2.6, negative because it goes up. And then we do 62.4 pounds per feet cubed. And then we do L2, which is 8 inches. We do the same conversion to going to feet. And in this case, multiplied by sine of 30. The last component is 62.4 pounds per feet cubed. And the elevation in this case, again, is 3 inches to make it into a foot. If you notice in this particular problem, we have 62.4 multiplied by 3 positive, and we have the same multiplication negative. So these two values will cancel out. This is for this particular problem. Okay, so at the end, we're just left with this number over here. PB is equal to 0.6 psi. And then this number becomes negative 54.08. And this is pounds per feet square. Once again, we cannot add these two figures because they do not have the same units. So we're going to convert into a PSI. And we simply say that 1 foot is equal to 12 inches. and we have to do it square. This value over here will convert into 0.3755 psi. Therefore, the value of PV at the end is equal to 0.224 psi.